Everybody, welcome to this 2024 Maths A IG Insights. If you see me looking left, it's because I've got two different screens going on here so that you can, if you've got any questions, you can pop it into the Q&A or the chat, which I've got on this screen. So I joined Pearson about 5 years ago to support schools around the world for maths. Before that, I was a maths teacher up here in the northwest of the UK for about 15 years, where I was a head of department. It's actually not raining at the moment in Manchester, which is the first time in about 2 days it seems like it's not raining. While I'm getting started, do drop into the chat, please. Say hello, what country you're joining from. It's always interesting to see where people are joining from around the world. I'll go ahead onto the agenda. So, what we're going to be going through today, just got a few notices of common questions that I'm getting from maths teachers around the world. We're going to look at the foundation tier insights and the higher tier insights. And I am going to say, I put this together with the examination data and the examiner's report. I'm not necessarily saying, those questions are there. These are the hard questions. We know the questions are at the end of the hard questions, or the questions at the start of the easier questions. I'm looking for where there's something interesting going on, where a question that is supposed to be straightforward, maybe a bit of it, the statistics say it's underperforming, and we're looking at why that is. Maybe we've just need to adjust the way we're teaching or the resources we're using. I'm hoping that on every slide where I'm showing a question, there's some advice that you can take back to your classroom to do something with. Please do judge me on that at the end. After the insights, we're looking at the tiering guidance, because I'm aware there's a lot of pressure around the world for people to be entered for the higher tier. So I see a lot of students who get too many students to get 3 on the higher tier, probably should have been entered for a 4 to get a 4 or 5 on the foundation tier. I'm going to give you some tiering guidance. And then we're going to look at resources to support the course. Just before we go on to the tiering guidance, before we go on to the insights themselves, I'm just going to say, if you haven't seen it as yet, this is for centres outside the UK. We have the alternative modular maths IG specification, so only for centres outside the UK. And I am getting questions around the world from people about, can I enter this exam in this exam window? So I thought I'd just summarize it quickly and clear up a few of the common queries I'm getting. So how can we enter students for if we're using the modular exams? Well, I get queries from centres saying, well, I want to teach linearly. Can I use the modular papers at the end of the linear course? Absolutely, you can. So you could enter both, say, the foundation 1 and higher foundation 2 in the same series if you think linear teaching suits your students. That kind of has an advantage if your students do have to resit. Maybe they've got a 4, want to push it to a 5 or a 7, and they need to push it to an 8 or a 9. Has the advantage that they could just resit one paper at a time in the 6th form, so less disturbance. So the main design of the course was for students to do the first exam in the summer of year 10, second exam in the summer of year 11. I have teachers saying, what I'd like to do is wait into the autumn of the second year, year 11, just when they've got a bit more maturity under their belts. Can I do that? Absolutely. And then you sit the unit 2 in the summer. And also just on terms of that tiering. So if you have a student go through higher unit 1 in the summer of year 10 and doesn't do well, you could try them in the autumn of year 11 in foundation unit 1, and then use that to decide for the summer of year 11 whether to finish off foundation unit 2 or higher unit 2. What you can't do is do foundation 1 and higher 2 and cash those in. It has to be both the foundations or both the highers. But I think that just gives a bit better information, that first live exam paper, those conversations with parents. The alternative is, if you've got foundation tier students and they do really well in the summer of year 10, you could try them on higher year 1 with support in the autumn of year 11, and then decide whether to finish higher 2 or foundation 2. So that's just the common questions I'm getting from around the world at the moment. Let's crack on with the insights. Okay. So, like I say, I'm picking out questions that I think performed, but there's something interesting about the forms that I think we can do something with. So I'm going to crack on with the foundation papers, and I am spending more time on higher because we do get a lot more entries for higher. But I thought it worthwhile just discussing some of those key things from foundation. So Foundation paper 1. So we've got a probability question here. I'm going to fire up the exam statistics. Now, if you see something in green, so this is ABC, anything in green was in the top 10 marks on that paper for that grade. So these are the parts A and B for all students were in the top 10 marks that they scored on that paper, or highest performing marks. So for the grade 5 students, 99% of them got that mark on 1, which when we look at this part C, and there is a theme that comes out of this year's, certainly foundation papers, but less so for higher tier papers, that when students are asked to do an explanation, so the probability Johan writes for bag C is incorrect, 1.2. Explain how you know it is incorrect. It's when we do an explanation, that's when the performance really starts to drop off. Now, we're not actually after a high level, we're not actually after a long sentence, and I'll show you what the mark scheme is. So we don't accept it is too high, for instance. We do accept it has to be below 1. But we're not after a very long explanation from these students. And I think my point is here that exposing these students to these questions, especially if you've got students entered for the autumn series coming up in a few weeks' time, that's why we wanted to do this feedback session now. I think there's still time to influence their performance on these questions, whether it by gathering questions together on Exam Wizard and asking them as a lesson starter in class just to regularly practice these, I think is probably important for their performance in upcoming exams. Foundation tier students, definitely simple explanations is one of the areas they struggle at. And it shows through on the next question. So just to give you some relative difficulty here. So this is where we're asking students to work out a value of X and give a reason for your answer. And then we're actually asking them to do for the next part something fairly complex. So let's have a look at those stats. So part A, where they've got to work out the value of X, students are doing very well on that. Part B, where we've got this shape here and we've got to work our way around it to work out a value of Y. Again, students, even grade 4, grade 5 students are doing very well on that. Anything to do with the explanation, and it is a simple explanation in here, even those students who did well on this second part are struggling on the explanation, even though I would argue this is a more complicated task that they're being asked to do here. So I think it's just a case of exposing students to a bit more practice on this. Here's the mark scheme. I'm not going to go through all the mark schemes. These are just when you get a copy of the slides later on, you'll be able to have a look and see how we're examining this. And there you can see that detail of how they're supposed to work it out and the correct reason. And if you see anything underlined in the mark scheme, those are keywords that we need to see. And just to give you an idea of how positively the examiners are marking, we need to see angles around a point add up to 360, or angles around a point add up to 360. You could do it in a number of different ways, but they're really positively marked. Even having said that, students are still not necessarily getting this mark compared to much more arguably complex tasks. Okay, so on to the next question. And we're going to have a look at paper 2 on foundations here. This is question 4, where we're working at sequences. Interesting again, write down the next term in the sequence, doing very well. That's for AII. Oh, sorry, I should say II. So some explanation questions when it comes to sequences, students can actually do quite well at. But here's another one. And I think it's just maybe that students have been exposed to this kind of question previously in class. It's quite a common one. But explaining why something is wrong is that next step up. Explaining why it is this, level 1. Explaining why it's not right, I think, and doing a coherent explanation is something, again, that those students struggle with. So, worthwhile, again, showing this to students in class, letting them write an explanation, and then showing them what is accessible, and more importantly, actually what won't get them the mark. I think that's kind of my summary on the explanations. Let's have a look at some shape and space stuff. So, question 14. Okay, so first of all, describe fully the single transformation that maps shape A onto shape B. And on the grid, reflect shape A in the line with the equation y equals 1. And I would like you to put into the chat which one of those you think the students will find the most difficult, A or B. So if you think A is most difficult, A, B is most difficult, B. Gives me a chance to have a sip of my cup of tea. Okay, you seem to have a consensus of opinion on A. Let's have a look. Where's my cursor? Here it is. Okay, I'll come back to that one. So yes, part A, where we're describing a single transformation, and the examiners sometimes say that students will put 2 transformations in here, and it's not, I don't think it's not that they think that's what they're supposed to be doing. I think they don't know how to describe certainly a rotation, and they certainly struggle with describing enlargement. Relative difficulty of questions here. We're asking them to identify where the line y equals -1 is, which is quite challenging for students. But actually, we've got some good evidence that your grade 4 and your grade 5 students are actually quite good at that. But for describing a rotation, and even a rotation about the origin, this is where a lot of these students are really beginning to struggle. So rotations, and from last year, definitely describing an enlargement, are topics to focus on with your foundation tier student. There's the mark scheme, so you can see it yourself when you get a copy of the PowerPoint through. And just to summarize for the foundations here, there's a few extra points that kind of I clocked in the examiner's report that I thought it's worth flagging to you. So based on the performance on this paper, students should learn formula so they do not get mixed up, for example, between area and circumference of a circle formula. I'm going to come back to how we can help with that in a second. No unit conversions, so students were struggling to convert between miles and kilometers, for instance. Know that there's 60 minutes in an hour, and for instance, be able to convert 9 hours, 36 minutes into 9.6 hours. A lot of evidence to say that students will just write 9.36 on this one. And in terms of exam technique, when drawing lines on a grid, these lines should be labeled with their equation as a master, of course, devising, for instance, 2 horizontal lines or 2 vertical lines being a choice of answers, and the students at that point, they score no marks. Learn that angles in a quadrilateral add up to 360, and be more competent with the use of negative integers in calculations. My question for you is, do you do an equipment check at the start of the exam? Or do you get somebody to do an equipment check at the start of the exam? The reason why I say, less so this year, but it did come through strongly last year, the examiner said they could tell when students didn't have the right kit. Maybe ask them to measure an angle. Maybe ask them to measure the length of a line to the nearest millimeter, for instance. How do the examiners know the students haven't got the right kit? Because literally the students are writing on the paper, I couldn't do this because I didn't have a protractor. Couldn't do this because I didn't have a ruler. I don't think we should be going into examination halls and asking the exams officer to say, put your hands up if you haven't got all your kit. But I do think, well, students are going to be stressed anyway. They're not necessarily going to want to put their hands up for that. I think we should be getting students to just put all their kit on the desk and do a quick scan of the exam hall. I can check an entire exam hall within about 90 seconds for 150 people. And at that point, you can make sure they've got the right kit, hand any that haven't got kit that need it, leave the exam hall and hand over to the exams team for that delivery of the examination. It's a quick check, but those could be easy marks that students are losing. And the final one, really, just practice those justifications with a little bit more emphasis on justifying why when something is wrong rather than justifying why something is the case, is where they seem to be struggling more at foundations here. And just to come back to one point, so it says, learn the formula so they do not get mixed up, for example, between area and circumference of circle formula. Although we don't give the formula for those on the front of the exam sheet, we do actually give the volume of a cylinder, and we do give the curved surface area of a cylinder. So with a little guidance, we can help our foundation tier students to extract area of a circle and circumference of a circle from those. That guidance about learning formula or checking formula comes through on higher tier as well, came through as well last year, I think it's students don't know, or in the stress of an examination, forget there's even a formula sheet there. And maybe one of the checks is just before you hand over to the exams officer team, remember people, check what formula is the first thing you do in the front cover of the examination. But let's have a look at how our higher tier students, and I'm going to spend quite a bit more time on this one. And I find it surprising sometimes what we think students can do and what they can't do. So Venn diagrams and set theory, I'm going to come to this explanation in a second, are surprising that some bits students can do really well. But I think there's a tip that we can give students. So let's have a look at this. In terms of that exam performance data, AI, quite well performed, was AII. So probably also list the number of sets that are not A and C. And my advice is to get students to write down what that means. So A even, so not even, and multiples of 3, I think helps frame that better in the students' minds and allows them to access that question. Sometimes there's opportunities to draw a very quick diagram. So 3 circles, labeling 1, even numbers, put in the numbers 23, 29, 31 in a second circle, and multiples of 3, labeling that circle as a multiple of 3. Even if we're not listing all these numbers in it, I think that sometimes frames it for students. I would say I see a worse performance on questions where we ask for instance, A prime rather than A, the complement of A. Those are the ones that students benefit a little bit more practice on. And if we look at that in the statistics, so part B, well, this is your higher tier students, give a reason for your answer. Overall, that was in the top 10 subparts answered on the entire paper. So evidence suggests that if you're seeing students who are really struggling with explanations, it might be that they're more of a foundation tier student than a higher tier student. Yeah, interesting sometimes what students can do and can't do. So focus on those A primes, get them to give a logical explanation of what this piece of maths means in terms of set theory. Set theory comes up again. I'll have to come back to it. Okay. Right. Factorize fully and then express as a single fraction. Interesting one on the statistics. I think when we ask students to add 2 fractions together or simplify 2 fractions, as soon as there is an unknown in the denominator, students start to struggle. There is a case here or further down of quadratics, factorizing quadratics, that is far less well attempted than this one. I think students, and far more straightforward, I think students sometimes struggle for some reason when it's an odd number in front of the x squared or the y squared. But it's worthwhile just practicing with your students those skills of adding 2 fractions together where there is an unknown in the denominator. I was quite pleased with the performance on this question. Even our grade 7 students, 55%, they scored 55% of the marks on this one. There's a couple of alternatives here in terms of 6y and y, and 6 and 2y and 3y, and also the fact it's slightly unfamiliar as well, because we're not asking them to factorize a quadratic and x squared, we're doing y squared. So I think that was quite a positive point that came out of the examinations. There's the full mark scheme that you can see for part B, but yeah, you can read that in your own time. This was an interesting question. So question 14, and I'm going to read through. So the combined savings of Abel Bahira are 15,435 dinar. The savings of Bahira are 45% more than Abel. The savings of Bahira are 3/2, 1.5 times the savings of Chanda. Work out the savings of Chanda. Interesting that the examiners say, so this is mid in the paper. Whilst many correct answers were seen, some students were unable to successfully navigate their way through the problem. I think this is a good one to do if you've got autumn term entries. I think it's a good one to do as a lesson starter in class. And when I was looking at the exam statistics of this one, overall, all students scored 37% of the marks. The grade 9s were 85%, and across the board, this was in one of the bottom 10 questions or subparts of the entire exam paper. So I think it's one worthwhile practicing. Just in terms of exam technique, I think students perhaps go line by line, working their way through it, instead of reading the problem and then thinking about where is the entry point for this. Okay, perhaps we should start with Chanda as effectively our base expression and saying that, you know, Bahira is some multiple of Chanda, so B equals 3/2 times C, rather than trying to work with Bahira as the one we're trying to work out and work backwards. So ask your student to step back from it. Where is the most obvious point that we can start that's going to keep the numbers nicest in this question? And it was a complicated question, but I think this was one of those. I'm going to talk about a mid-paper dip later on. And a lot of these questions that I'm selecting that I would think, perhaps students should be doing better than that, tend to come from the middle of the paper. And I'll perhaps talk about why that perhaps maybe in a little while. Okay, so surds, a very interesting one. So the examiners do comment that students were less successful in producing a full treatment of surds, potentially even than last year. I think I've seen in kind of the exam statistics that once students have confident enough to have a go at it, they can then get the majority of marks in the question. What I do tend to see is students not even starting it, perhaps because they think they can't walk through to the end, work all the way through to the end accurately. But I think it's a real conversation with students about just beginning on questions. And here's where it shows up. So it's definitely one that your grade 7 and below students struggle with. Now, I know we've got a lot of grade 7 students that go on to do A-level and international A-level. And it came through clearly in the examiners' reports for the pure papers for international A-level this year that confidence on surds and confidence on fractional and negative indices were absolutely vital for their success on international A-level. And it held back a few questions on a few questions because of their skills on that. It prevented that access into the question. So I think we need to be talking to our students about just having a go. I'm going to talk about the mid-paper dip in a little while. But yeah, surds is definitely an area to just keep practicing on for your higher tier students. And I have some resources toward the end of this session that you can get you access to that will help you to do that. Okay. I've got two questions for you now. So I've got a curve C has the equation y equals x cubed minus 40x. These are both 5 markers, by the way. Find the coordinates of the point on C at which the gradient is 8. And secondly, a quadrilateral, work out the value of x, given your answer, correct 3 significant figures. So here we've got to differentiate, set our differential equal to x, and then potentially solve a quadratic for the 2 points. And here we've got to apply the sine rule for this triangle and then apply the cosine rule for this triangle. Which of those two do you think students found harder? Please, it gives me a chance for a sip of tea again. Please drop that into the chat, A or B, as to which you, sorry, 18 or 19, I should say, which one you think the students found hardest. Lovely, common consensus in the chat. I can see Panos has gone with 18. Hello, Panos. I think we've actually spoken a few times. Ooh, Ali says 18. Aya says 19. Whoa. I love it the way it starts off with a common theme of 1, and then people are deciding whether to go against the flow. Here's the data, people. Question 18 was far more difficult for students than question 19. Now, I am going to talk about 19 a little bit, just more as a comparative that students can actually do. So it's really refreshing to see that students can do some really challenging stuff. I really like to celebrate their successes. So even your grade 6 students are getting 50% of the marks here, where they've got to select the 2 correct trigonometric techniques in the correct order. There's a lot of opportunities for using numbers in the wrong place with these. Fantastic that they're getting these marks. And yet, on a differentiation question, the average mark was 41%. As soon as we go below kind of a grade, and I should say this should be moved along one. As soon as we go below a grade 9 and go to the grade 8, students start to struggle. Now let's have a look at the mark scheme for that. So we've got to differentiate it, and we allow 1 mark for differentiating one of the first 2 terms, an accuracy mark for differentiating the first 2 terms, a method mark for setting that equal to 8, and then a method mark and an accuracy mark for solving that and working out the other 2 coordinates. And yet students are finding that more difficult than applying the sine rule and the cosine rule. I think it's potentially a topic that we've underestimated in our teaching about how difficult students find it. My advice would be that for international A-level or UK A-level, students get to grips with differentiation fairly quickly where y is a function of x. And then it's almost harder to move them on where x is a function of t for speed, distance, and time. I've looked through the exam statistics. I think students at international GCSE level tend to do better where it's in a more concrete context. So introducing it via x is a function of t, talking about the velocity being a differential of that, the acceleration being the differential of that gradient of that graph, and then moving them on into the differential, y is a function of x, perhaps might yield better results from students rather than just going straight in with y is a function of x. It's that concrete, pictorial, and then abstract. Worthwhile considering for your pupil as to whether that would, to make inroads into that. Worthwhile considering how much time you spend in your scheme of work you actually dedicate to differentiation. It might be that we're just underestimating how difficult students find introducing that new topic. And the examiners did say students who appreciated that this question required calculus usually gained at least 2 out of the 5 marks by differentiating. Some of the students only worked out the positive value for x and ignored the negative value. Some students did not realize that when they square root, it should lead them to 2 value of x, as the question asks for the 2 points of a curve. Yeah, fascinating when you compare this to that kind of advanced trigonometry question. And I would say this is definitely an advanced trigonometry question. Selecting the sine rule and then selecting the cosine rule, there is, to me, a lot more opportunity to make mistakes in that than a differentiation. And it may be just a slight tweak to the amount of time we spend on differentiation, or its emphasis within a revision could actually pay dividends in terms of those grade outcomes. Okay. That's paper 1. Now have a look at paper 2, which is also an interesting one. And I've got it all up on the screen here for you so you can see straight away. So on the grid, draw the straight line with the equation y equals 2, x equals 6, and then y equals x plus 1. And then we know this last part is actually going to be fairly tough, but I want you to look at those grade statistics. So 90% of all students could draw on y equals 2. 90% of all students could draw on x equals 6. 67% of students could draw the line y equals x plus 1. So we've not at this point here asked them to do any inequalities at all. However, I mean, classically, in my head, students drawing y equals 2 or x equals 6 is potentially more challenging for some students than y equals x plus 1. But when we're actually looking at the grade statistics, as soon as we drop below a grade 7, those students are genuinely struggling. So even the grade 6 students can plot horizontal and vertical lines, but only half of them can actually plot y equals x plus 1, which is slightly worrying. And it actually comes through something else the examiner said about gradients that I'm going to talk about in a little while. But that's even before we actually get to the inequalities. But actually, if you look at the inequalities, students actually did okay in terms of identifying that reason. In fact, we see a jump up from the statistics of this one, because in relation to their own lines, they're actually quite good at drawing those inequalities. This is what I mean about some questions being, that's interesting that students have performed in that way unexpectedly. Equations of lines, even basic ones, seem to be harder than identifying regions on inequalities. Now, there's an interesting thought and slightly worrying. Okay. Okay, this is an interesting question. So change a speed of W meters per second to a speed in kilometers per hour. Give your answer in terms of W in its simplest form. So in some ways, this isn't a surprising one that students struggled on this one. I'm going to fire up the statistics. So, sorry, that's the all statistics. So only 44% of students could actually get that mark, and only 8% of grade 9 students could get this one. I think it's one that is worthwhile just practicing with students as a lesson starter, because I think it reveals some misconceptions. I think the classic one that I used to do with students is there's 7 days in 1 week. Find me an equation that links days and weeks. And I think it reveals a lot about students to just pop that up on a whiteboard. And it's good to create that, what's the phrase, cognitive dissonance, where they're really, really thinking about it. So yeah, and it definitely an interesting one to discuss with your students, but more one probably to use as a lesson starter. Okay, now this is one that I did think definitely underperformed and is worthwhile just thinking about why. The examiners did say a well-answered question on combined mean with many fully correct responses seen. But many students didn't know how to combine these. And I've actually got the statistics here of this question and the ones around it. So here we go. And here's this question. On the face of it, there is nothing overly technical in this. And actually, when you've got a copy of the paper to hand, have a look at the questions around it. I think this question definitely underperformed. And I'm going to talk about what I said before, that mid-paper dip. So what I tend to see when I'm looking through the exam statistics, we know the questions at the start are going to be quite straightforward. And there's less instances of those questions behaving in odd ways. Likewise, the questions at the end are designed to be challenging. And again, those questions tend to perform as expected. What we sometimes see is some questions in the middle, students losing marks that they really shouldn't be doing. I'm going to put a hypothesis to you. Feel free to say whether you agree or disagree. I think students know they can answer the questions at the start. Sometimes maybe underestimate those ones in the middle, but know they have to brace themselves for those questions at the end of the paper. And I think when we ask students to check, we've got free time, check your working, go back and check what you've done. I think that's almost too big a task for students to think like, oh, I've got to check the entire paper. Okay, I'll just check something relatively straightforward I can check. I think we can help the students make that more manageable and say, if you're going to make silly mistakes, I don't like that phrase, but it's what the students use. It can be more likely to happen in that middle of the paper. So if you're going to spend 10 minutes checking, go and check your questions in the middle of the paper, where you might have assumed that it was easier than it was actually designed to be. But the examiner said, some students, however, did not know where to start and presented a solution that involved adding the means and dividing by 2, so finding the mean and the mean. There's some lovely misconceptions in talking about this question in class. Why can't we just find the mean of the 2 means? Under what circumstances could we find the mean of the 2 means? Now, there's an interesting diversion for this question. Or maybe they even divided the mean by 4, the mean for 4 days by 4, and the mean for 3 days by 3. And the examiners did say these incorrect methods, of course, gain no marks. But we have seen this question before. It's actually, if you've got any children doing the 11 plus, it's one of the ones that comes up quite often on there, that a football team score over the first average over the first 6 days of the tournament was 4 goals. On the final day, their average was now 6 goals. What was the score on the last day? Those can be quite common questions at this kind of level, and at say 11 plus level. So I think this is a good one to take away to discuss with your class of what do we have to do? Under what circumstances could we just find the mean of those 2 means? I think it's a good misconception resolve with this one. Again, one to do in class. Okay, on to another question where I'm going to ask, which one do you think students found hardest? Make G the subject of this equation here, or solve this inequality. It's 4 markers for the first one, 3 marks for the second one. Which do you think the students found hardest? Mix of answers, I like that. Bit more of a weighting towards A. Bad news. It's B. Okay. Sorry, guys. I think this is a really nice indication. Make G the subject. Make G the subject of E equals. I think it's something we should celebrate. If 65% of all students are getting that correct, and even 70% of grade 7 students are getting that correct, I think we should celebrate that. And I think you should celebrate that in terms of what you've achieved with your students. We should not underestimate the level of complexity that students are very much capable of achieving. So here, got to square both sides. We've got to multiply both sides by a denominator. They've got to collect like terms with G. They've got to factorize out the G, and then they've got to divide by a bracket. And yet, solving an inequality, students scored fewer marks. So only 40, the average percentage there was 49% on this question here. I sometimes see in the statistics that students are a little bit less confident at solving when it's oddly uneven number of x's or y's. And again, this question here is a y squared. The one before was a y squared, but neither of them are x squared. I can see why students may struggle in the latter part of the question in terms of those critical values and interpreting them in terms of the regions. Still, I think students are actually struggling with more of the factorizing the quadratic than arguably something that is a lot more complicated. And I like this one here because it gives us a nice demonstration of actually sometimes we need to raise our expectations of what students can achieve, because this is what they're doing. This is what they're achieving in those live examinations. I think it's an interesting one. You know, the previous one we had where students we talked about was 6y squared. Whether it's that the inequalities threw them slightly and thought, okay, can't get to the end of that, so I won't begin, may have been a thought process going through students' mind. But actually, we need to encourage them to look at this and go, actually, for getting to the point of just solving a quadratic is 2/3 of the mark. And I don't see any reason why any student of a grade 6 and above couldn't solve that quadratic. It's only going to be 3y and y. There's no alternatives like the one before where it could have been 6y and y or 2y and 3y. So we need to be just highlighting students that sometimes we don't need to be able to get to the end of a question in order to be able to pick up the majority of the marks on it. That's my point on this one. But I also wanted to celebrate with you how well students can do on some pretty challenging maths. I think we should celebrate that. Okay. Back to Venn diagrams, which came up again. Well, not necessarily the Venn diagrams, but 2 parts to a question. I like these questions. I find them quite challenging. I know it's the kind of question that some teachers do for fun. I do. 60 art students were at a tender workshop for knitting, photography, and embroidery. And part A, using this information, complete the Venn diagram to show the numbers of students in each subset. I think that's challenging. Part B, find the probability. So given that a student chose photography, find the probability that this student chose knitting. Find the number of students who did photography and didn't knit. And then we've got another bit down here. And I'm going to show you the statistics. Okay. And I wanted to highlight this to you, that students are actually very good at filling in Venn diagrams. 3 marks here. 97% of grade 9 got that right. Even 63% of grade 6 students could fill in the Venn diagram. But then it really starts to tail off when we ask them to do things with the Venn diagram. Okay, so part B, probability, and then part C, number of students. I think students struggle with the N notation. But I think, again, we sometimes see a drop off in the statistics when we have, say, K prime or K dash, and it's worthwhile practicing those students. I'm not surprised slightly by this part D being difficult, because there's two different things going on in here. But again, the idea of writing down a written interpretation, number of students who did photography but and did not knit, is a nice way to help students to frame it in their mind. And do focus on the N open brackets meaning. And I think we can help students avoid losing marks easily. I always used to say to students, it's okay to lose the marks you can't do. It's not okay to lose the marks that you can do, but maybe you didn't just quite show it in the right way for an explanation or something almost trivial that we just need to maybe remind them of in their revision, because they have got a lot going through their heads when we're coming up for exams. Okay. Remember I was talking about equations of lines before. So it was that students could do, was it y equals 2 and x equals -1, but they couldn't plot y equals x plus 1, and yet they could identify regions on linear programming, which, let's face it, is pretty challenging. So here's a question. The gradient of a line P is the equation 5y plus 2x equals 7. Find the gradient of the line that is perpendicular to P. So we've got to rearrange it first of all. And remember, we've also said students are actually very, very good at rearranging formulae and rearranging equations that are far more complex than this. Here's the grade statistics. So it's out of 2 marks. Once you get below a grade 8, and even grade 8s are only 3/4 of them are getting, students are only getting 3/4 of the mark here. But grade 7, they're getting less than 50% of the marks on this question. There's the mark scheme. Gradient of P equals -2/5. Then they effectively have to construct the gradient of the perpendicular from that. And that gets them the 2 marks. The examiner said this, and it was quite shocking to me. So let's have a look. This seemed like a very straightforward question for the grade at which it was targeted. However, we are now of the very strong opinion from the evidence from a great number of students that many do not actually know what the gradient is. We were very surprised that most students seem to think that a gradient is a value with an x, or an equation 2.5x, 5/2x. We're commonly seen as the gradient, as was the equation with the gradient 2.5. We would strongly recommend that students are taught that the gradient is a numerical term and not a number with an x attached. For this reason, many students only gained 1 mark because we wanted to see the gradient stated correctly as a numerical value. We know students find equations of lines challenging. We know that. But I'm going to remind you of that in the context of students being able to place y equals 2, x equals -1 on a graph correctly, and shade the correct regions in relation to y equals x plus 1. Worthwhile building in some more time into schemes of work to either teach this or revise from it. I've just seen Bilal's comment here on vectors. So could you explain the steps, points necessary for vectors, as they are quite lengthy? Absolutely right. A lot of the vectors questions are at the ends of the exercises. The examiners what does come through quite strongly is drawing a diagram is absolutely the key for vectors. It's something I can cover in future sessions if people think it's worthwhile doing a session on vectors. I'm going to say, if you're not on Exam Wizard, go see your exams officer after this session and get an access to an Edexcel online account, which gets you access to Exam Wizard, which then gives you that range of questions you can look up. And Bilal, although I'm going to say that the students find the vectors questions hard, you go on Exam Wizard and fire up a load of vectors questions, you could actually see that they're all hard, but in a very similar way. There is actually not much variation between the vectors questions. And I think once we tune students into that underlying structure for maybe forming a couple of equations, solving them simultaneously, I actually think that that pays dividends. Interestingly, from the vectors questions last year, it came through that students could actually form the simultaneous equations, but then just stop there. So with simultaneous equations that weren't in X and Y, they didn't see that they had to solve them as simultaneous equations. And when you're teaching simultaneous equations, as they said to me on my teach training, vary the irrelevant variable. Make sure it's not just X and Y, make sure it's A and B, make sure it's P and Q. I think is something that will pay dividends for that. So yeah, that interesting point of they could realize they needed to form simultaneous equations, but then didn't solve them, and yet later on in the paper were solving simultaneous equations questions in X and Y. Absolutely fine. So that's our equations of lines. So based on the performance in the paper, higher tier students should learn what is meant by a gradient, be able to differentiate the statistical terms such as mode, median, range, and mean. If an extra piece of paper is used, indicate which of the solutions in the answer space or the additional response is the intended solution. Improve understanding of set notation, especially with n open brackets. Know how to use the trigonometric functions correctly and how to label triangles correctly with offset, adjacent, and hypotenuse. Know how to manipulate speed, distance, time for formulas, something that came through for the exam. That's things that students are struggling at. And identify between simple and compound interest and know how to apply each method. So in one of the questions in the paper for the compound interest, students were regularly applying simple interest. Now, I don't think it's that students thought that was the way to solve that question. I just think that's an indication that students didn't know how to do compound interest and were just applying simple interest in the hope of maybe picking up a mark or two. I don't think we should read into this that students think you solve compound interest problems with simple interest. I think we should read into it that they were just fishing because they just didn't know how to do compound interest problems. Always interesting to try and read between the lines as to what potentially the underlying cause is. Be able to use formula given on the formula sheet. The students are reminded that the formula for the cosine rule and the sine rule are given on the formula sheet, as some students quoted the cosine rule and or the sine rule incorrectly. Likewise, I think it was the volume of a sphere last year, students were getting the power wrong and it was on the formula sheet. How often do you refamiliarize your students with actually what is given to them in an example that's used? And be able to apply differentiation to a problem. So last point on this one, students must, when asked, show their working or risk gaining no marks despite correct answers. It's a key point from the exams. Okay, so on to just some guidance on tiering before we just do some resources. So there are, in case you haven't noticed, the rear 40 marks of the foundation tier paper become the first 40 marks of the higher tier questions. And that is key for part of the grade setting process to make sure that the distributions are correct at foundation and higher tier. I use that data to try and gain some insights to give you advice in terms of tiering. Now, this is all the data for, say, the 1F and 1H. And if you're doing the 1F and 1H this year as your mock, take a look at the summation, not necessarily each individual question, but the summation of those crossover content. And I'm going to summarize this one in a second. I want you to notice something here. Say the foundation students scored an average of 25.4 and the higher tier students scored an average of 24.19. Come to that, I want to show you the paper twos. Paper 2, foundation tier student grade 5, 27.67, higher tier 26.45. Why are the foundation tier students doing better slightly? And this is a pattern that happens more often than not, I've noticed. But the foundation tier students tend to do slightly better on the crossover questions than the higher tier students. And I think it's because that's the back end of the foundation tier paper. And when students are revising for examinations, they're concentrating on those harder questions for them, or the teachers are giving them plenty of practice on the harder questions. And yet, for your higher tier students, it's the back of their papers that they're being focused upon. So not necessarily those first questions. I don't think we should read too much into this. It is just a pattern I've noticed, and I think it's because the higher tier students, they're focused on the last questions in the higher tier papers. What does it give us? Okay, here's the summary of them. So if you're doing both the paper 1 and paper 2s, maybe a student's doing both Foundation 1 and Foundation 2 as a mock. Okay. If they're getting in the 53 marks, so this is the average marks of grade 5 on foundation tier student, and higher tier student gained 50. We're not really trying to ask if a student would get a 5 on a foundation tier or a higher tier. What we're really trying to ask is if could a foundation tier student, if with a bit more support, gain a 6 on the higher tier, or have we got any higher tier students that really shouldn't be doing higher tier? And I would argue that if they're kind of getting in the grade range of a grade 3 on the higher tier, then perhaps we should consider whether they'd be able to get a 4 or a 5 on foundation tier. But if you've got foundation tier students, and on those crossover questions, they're clearly getting in the grade range or the mark range of students who scored a 6 on the higher tier, then perhaps it's worthwhile considering, especially if you're doing a mock before Christmas and they're already getting in this mark range, but they're not the finished article yet. Perhaps you should consider whether it's worth, whether they would cope with that, just that extra bit of work to get them up to the higher tier in the second half of this year. Only your knowledge of how the students cope under pressure can determine that one. But just to give you an idea of how many more marks they need to get. So on the higher tier 1, the grade boundary for a 6 was 40, higher tier 2, 43, higher tier, combination of them, 84. I've just seen Lara's comment. You'll get a copy of the slides sent to you afterwards with links to this data. Okay, so if a student scores on the crossover questions 61 marks, they only need 23 marks in the remaining marks of higher tier papers to get them to achieve a grade 6 at the higher tier. So, we're only talking an extra 10 marks per paper out of the remaining 60 marks. So if they scored 10 marks out of the remaining 60 marks that are not the crossover questions, they'd be knocking on the door of getting a grade 6. So it's worthwhile just considering that, but only if you think they can cope with that stress and pressure of the material they have to study. Okay, so I hope that's useful on that tiering guidance. Okay, just in terms of resources, so, and this is for those into non-UK schools have the option to do this first part, or the option to do the modular version of the specification. I've done an analysis of the textbooks, and the nice thing is 37 out of the 50 chapters across the textbooks are either entirely contained in Unit 1 or contained in Unit 2. Of the remaining 13 chapters, I've done a line-by-line breakdown of exactly which question to either move into that one or use as a revision when you're doing Unit 2, but it's there. But as I say, 37 out of 50 chapters are entirely contained within the new Unit 1 or new Unit 2. This spreadsheet should be going up on the website by the end of the day, be in the teaching and learning resources section for you, just to give you that bit more confidence when you're teaching this. This resources team are working on a modular version of the textbook at the moment. I'll give a date of when that may be out. So just to go back to some of those topics that we started. Oh, I've just seen Joe's note there. Joe says it's already on the website. Joe, if you wouldn't mind throwing that link into the chat for me, that would be most appreciated. Just in terms of those resources, so we said that certainly for your higher tier students, indices, rationalizing surds is a common topic that students struggle with at international GCSE and international A level. Thanks, Joe. There's a link in the chat for those of you that can take the modular specification. We have, we can use this for supporting research students. We actually have a separate website in terms of transition videos from GCSE to A-level maths or IG to IL maths. And this is where we took all those common topics that are in the top end of IG and cross over into IL maths. So surds, solving quadratics, indices, rationalizing denominators, they're all in common. So we actually used the examples from the A-level textbook, so you've got something else to work with, and created videos for them. Now there's about 10 hours of videos, and you can use these in a number of ways. So you can use these if your students are taking UK A-level or international A-level as intervention resources. You can use them as crossover resources, across the summer work for students that are intending to take the international A level or UK spec. Or you can use them as boost and intervention resources for those hard skills within year 11. So it's broken down by sections, so expressions, quadratics, equations, and inequalities. You can start to see the breakdown there. For each of these, there is actually a video. There's about 10 hours of videos of me wittering on, I'm afraid. Can't stand the sound of my own voice when I'm recording videos. But there's about 10 hours of videos walking students through examples with commentary and just talking about those finer points of what we're looking for when we're doing this kind of work. There is also a support worksheet from past exam questions that includes examples and then questions for them to work with. The other thing that we have, so I think that's a great resource for boosting those key skills, whether you've got year 12 or year 11 students this year. The other one that we've got coming out later this week is we've got our new enhanced QLA, which gives you a red, amber, green rating for questions. So this is the 2024 summer papers. We'll be working our way back through previous series, but this is slightly different from other QLAs that you might have used. So instead of red, amber, green rating them based on the actual number of marks, say if it's out of 2 marks, green for 2, 1 for amber for 1 mark, 0 for red, we've actually done something slightly different in here. So let's have a look at 2 5-mark questions. A student scores 2 marks on one, gets an amber, 2 marks on the other one, and gets a green. How have we done this? Why does it work? What we've actually done, as you can see down here at the bottom, we've imported the exam statistics of the live performance data, because getting 2 out of 5 on an easy question is entirely different than getting 2 out of 5 marks on a much harder question. And so the QLA should give students feedback based on that. It's entirely different. There's no macros, so it's not locked down by any computer systems. There is effectively a summary sheet where you can put in a grade, where it will actually give you an on, above, or below count. There's arrows here because I'm aware you're going to get told off as teachers for printing in colour. There is a student feedback sheet, which actually gives the students the exam performance statistics, and they can see question by question how they performed compared to the other students. So there's a link at the end of here for you to follow me on LinkedIn, or a QR code. Please do follow me on LinkedIn. I'll be messaging about that later in the week. But it's just a nice way of getting a bit more detail about how your students do. I should say it is all completely flexible. You can actually replace questions. So say you've got students that haven't quite covered enough material to do a full paper, you can replace it with other performance statistics and other questions. And where do we get that from? Well, all the data from today is on the Maths Emporium and covers anything you might need in terms of if you want to replace things in the QLA. So there's a link here in the spreadsheet. And then finally, we've got upcoming training. So we've got the regional IG Maths papers next week for teachers that are taking exams, students that are more than 3 hours away. We've got understanding assessment and improving outcomes for international A level. We have getting ready to teach modular for our international GCSE and the equivalent course for our international A level. We are just about at time. There's a lot going on in there. I hope it's been useful. Please do give us any feedback. I'm going to put my QR code up if you want to follow me on LinkedIn for the latest announcements. But please do give us feedback. I'd love to know whether you think for each of those slides, whether I've given you anything, something that you can take away at the end of the session. So you'll be sent a copy of the slides after with all those links, and I hope you found that useful. I'm going to switch my camera off for a second now because that's the end of the session. We're going to leave this slide up for a second, but like I say, you'll get a copy of the slide, which will also have the link. And hopefully you found that useful. Have a good evening, everybody. And I'll see you again soon.